Neural networks are one of the most fascinating and transformative technologies in the field of artificial intelligence. At their core, they are computational models inspired by the structure and functioning of the human brain, designed to recognize patterns, make decisions, and solve complex problems. While the term might sound intimidating at first, understanding the basic structure and function of neural networks reveals their elegance and simplicity. They consist of layers of interconnected nodes, or neurons, which work together to process information and learn from data. A neural network typically has three main components: an input layer, one or more hidden layers, and an output layer. The input layer is where the data enters the network. Each node in this layer represents a specific feature of the data, such as pixel values in an image or numerical attributes in a data set. This information is then passed to the hidden layers, where the real magic happens. Hidden layers contain nodes that are connected to the previous and subsequent layers through weighted connections. These weights determine the importance of each connection, and they are adjusted during the learning process to improve the network's performance. The hidden layers apply mathematical transformations to the input data using activation functions, which introduce nonlinearity and enable the network to model complex relationships. As the data flows through the network, it gets refined and transformed until it reaches the output layer. The output layer provides the final result, whether it's a prediction, classification, or decision. For example, in an image recognition task, the output layer might indicate whether an image contains a cat or a dog. What makes neural networks so powerful is their ability to learn from examples. During training, the network is presented with labeled data and adjusts its weights to minimize the difference between its predictions and the actual outcomes. This process, known as backpropagation, uses algorithms like gradient descent to iteratively improve the network's accuracy. Over time, the network becomes better at recognizing patterns and generalizing to new, unseen data. Neural networks come in many forms, from simple feed-forward networks to more advanced architectures like convolutional neural networks, CNNs, for image processing, and recurrent neural networks, RNNs, for sequential data. Despite their differences, all neural networks share the same fundamental principles of learning through interconnected layers and weights. Their versatility has enabled breakthroughs in fields ranging from natural language processing and healthcare to autonomous vehicles and financial forecasting. For beginners, the key to understanding neural networks lies in breaking down their components and seeing them as systems that mimic human learning. Just as we learn from experience, neural networks improve by identifying patterns and making adjustments based on feedback. With their growing accessibility through frameworks like TensorFlow and PyTorch, neural networks are no longer confined to research labs. They are tools that anyone can explore and leverage to solve real-world problems.